Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of our educational event today is slicing up the world into discrete entities, vision processing for AI. As the topic suggests, the topic of today touches on technology and specifically on AI, but it also touches on human psychology, which can be applied to create the technology for artificial intelligence. I can say that we have an irresistible tendency to set up a material universe that is discontinuous, composed of bodies which have clearly being defined. They have outlines and we have the tendency to change their place, rearrange them, and find their relations with each other. Each one of these leads us to distinguish, besides our own body, to distinguish other bodies which are independent and which we must either seek or avoid or classify. Our needs are then so many, like searchlight, which directs upon for continuity of finding qualities single out in distinctive bodies. Our senses, like sight, sound, touch, creates a continuous and fluid experience of the world for us, both in space and time. Within this flow of colors and sounds, there are no objective delimiters where our mind is required to cut the stream into distinct objects and events, no clear markers to designate where anything starts or stops. Our visual inputs cannot dictate, say, which span of the morning constitutes the dawn, or the morning for that matter. And although it is possible to come up with ad hoc definitions by which we may recognize an object or event, there will always be exceptional cases which reveal how bespoken, ambiguous, and contrived such definitions are. Despite all this, we can and actually do in fact slice up our experiences into identifiable objects and events. Life, moreover, demands that we think and act discreetly and decisively, especially when we must decide to take some definite action, for example, to go to work or stay home. From this necessity of acting decisively and discreetly, we can work backwards to the requirement to think discreetly. If we're planning a party and each guest needs 2 or 3 slices of pizza, we must decide how many guests will be present, how many are allergic to gluten, how many are children, and etc., and multiply the results by the appropriate number of slices. Nor we can dodge this requirement for discreteness when calculating probabilities, since these two require that we first define discrete variables or terms over which we perform our calculations. Calculating the probability of contracting a disease is only possible and only makes sense if we can recognize what does and does not qualify as having contracted a disease. When was the onset of the disease, and etc., as well as what counts as an individual person. Do conjoint twins count as one or two people? So before we begin, we must make all or nothing decisions to define the parameters of the activity. The question is how can our mind make these decisions given only a continuous stream of inputs where stimuli blend into one another, and where any subset of inputs may be part of any object. In the classic paradox of the ship of Theseus, individual planks of wood in a ship are replaced one by one until none of the original wood is left. The precise moment when the ship stops being the ship of Theseus cannot be determined by our experiences of the ship itself. The boundaries of objects or events must always be constructed and enforced by the mind that perceives them. This is not to say that the decision is a random one, unconnected with what we see, but rather that such information is not contained within the sensory experiences themselves. It must come from outside us. Sensory experiences are like an ever-flowing river, and the river cannot divide itself into pieces. It has to be cut up by some external force like a rich boulder or gravity. So to split up any continuous space of inputs into chunks, there must be a reason, an epistemological knife, a trigger that detects some feature in space or time and decides to cut the experience at that point in that manner, and so far. In the example of the ship of Theseus, such a knife may detect, say, a shift in the proportions of colors or contrasts of the ship's wood, or a change of the captain, etc. And from this make a distinction between the old ship and the new ship. The problem with this approach is it leads to an infinite regress, since the trigger itself is based on a discrete event, and we must decide how and now why that trigger was defined the way it was, and so on. At some point, we must end up at hard-coded starting point of this chain of discrete, determining discrete events. But now, how could that exist if we don't know in advance what the determining factors should be? How could a single hard-coded starting point be universally appropriate to all instances of identification, from sunsets and ships to families and forests? Um, how to address this with um, applying this to artificial intelligence? We might look to instructive examples in modern AI for an answer. Dividing data sets into entities or samples for training and inference is a critical step in all machine learning models. So far, however, the question has produced no universal solution. Rather, it is decided on an agent-by-agent, task-by-task basis, guided by the problem it is intended to solve. For example, an image classifier divides its input space into individual images along with their labels. The software architecture and pipeline automatically separate and performs regressions with respect to this pair. Even when the images appear in sequence, there is assumed to be no relationship between two consecutive images. On the other hand, a simple video classifier draws the dividing line between videos of multiple constitutive images which are assumed to be related within a given video. Or we can consider pixel by pixel segmentation models which subdivide images into the objects they contain. This requires training on hand-drawn discrete cutouts or so-called segments to learn how to identify the boundaries of objects. As for language models, they ingest their input data split by words, lemmas, and sentences. They are not exposed to language through undifferentiated streams of color images mixed in with the rest of life experiences, as in the case of humans. Multimodal language models combine all the above images, videos, words, and use the word separation inherent in the language streams to cut up the images into sub-segments. And reinforcement learning models usually distinguish only between individual video frames and subsequently can only predict entire frames, not the objects within them. Finally, all classical logic models require the data to arrive pre-categorized into logical terms and operators. In none of these cases are data presented as continuous stream of input. Buried within any machine learning paper, we can find the initial assumptions for how the data must be segregated to serve the task at hand. The data, the task, the regression schedule, and even the pipeline architecture define the units of entities involved, and all subsequent separation um, happens as a consequence of these initial decisions. This is part of the definition of narrow AI. Narrow AI defines its samples, variables, and units of data based on what it deems to be necessary for its specific task. The real world, of course, does not tell us where a word, either written or spoken, starts or ends, nor can experiences themselves inform us which subset of our visual inputs count as a living room or which ones are a kitchen. Our mind must make these distinctions itself from its standpoint within the empirical flow. Of course, once we have reached a certain level of maturity, um, identification comes so naturally, so easily, that it is tempting to project this decision into the world as though the world itself is telling us that such and such is where a kitchen starts and ends. So when we identify any instance of an entity, it is tempting to look back at what caused us to recognize it and assume that was the trigger. For example, I identified a car by its shape, so it must be the shape of the car that caused me to learn to identify it. But this only applies in cases where we already know how to identify the item. That is, once the work is already done. Effortless acts of recognition are the product of prior learning and decision making, which is now producing the habitual response so automatically that the mind appears to be a follower and not the leader in this process. Only when we encounter exceptional or ambiguous cases where the decision is not clear, or on what criteria would we decide dogs from walls, for example, do we start to suspect that it is ourselves that we are following. And to be clear, this is not about what the correct definitions or criteria are. It is about how the mind arrives to its tentative conclusions, correct or incorrect, and what leads it to make that distinction. That is the core challenge in this presentation, the distinction, unification dilemma. The most intuitive explanation for how the mind splits up the world, one that is implicit in nearly every cognitive scientific theory of recognition, is similarity. It is the repetition of certain inputs in space and time that through overlap lets us know that a common item or event has been presented to the mind. let's put aside for now that this approach falls when applied to abstractions like government or existence. Even for concrete objects like a chair, the decision of how to split the world cannot be caused by similarity in appearances alone, um, as we will see in the example of identical twins. Um, Imagine an AI that has to distinguish between identical twins. At some point, it must make a discriminating decision. That is, it must decide on what basis it will distinguish that um, there are two humans and not just one. Unfortunately, they look quite similar. All humans look slightly different from day to day, so the presence of small identifying marks is not enough to force the agent to decide that there are two separate entities involved. Even if we see the twins side by side, this may simply be an illusion. Perhaps the second person is a reflection in a mirror or a video of the first person playing beside themselves on a screen. The agent may not even witness for itself that there are two people, but may only be told by others that two experiences of a person, one on Monday and one on Tuesday, were actually two different people instead of just one. In short, there are no sensory criteria under which a mind would be obliged to separate the twins into two separate entities instead of just one entity. To address this problem, the next intuition may be to look to associated nearby correlations such as names or identifiers or clothing, um, like as being the reason the mind distinguishes the people involved. For example, if the appearance of one of them is followed by the name of Kevin and the other one by the name of Kent, this might be enough for the mind to decide their distinctive entities. However, this only pushes the question back since the sounds of those names, as we hear them, are not themselves discrete entities, but rather appear within a flow of other sounds. Discreteness can only be signaled by other discrete triggers, so distinguish the twins by association with a nearby stimuli is like trying to cut a river with another river. If their names are Kevin and Kent, one alternative may be that our mind extracts the common sound ke from the continuous space of sounds and uses it as their joint identifier. Presumably, this is how we identify any other person's name based on the overlap of sounds we hear associated with them. So why not assume that there's just one person named Ke? The agent is therefore left with a dilemma whether it can distinguish the twins based on the sounds of their full names by incorporating the uh, additional unique syllable K plus win and K plus NT. Or this can be the common element within the flow K. So we have to choose one of these two different paths and pick and make one decision based on two different choices. Any theory which tries to rely on similarity or association to extract entities from the flow of experiences faces this irreconcilable dilemma. Reasoning using only the stimuli themselves or trying to rearrange the stimuli into some general logical principle of distinction will always fail. In the case of the identical twins, it is obvious there must be something outside the immediate stimuli to give us a foothold into the process, to push us one way or another, to separate the two entities based on discriminating inputs or unite them under what it is common. Errors in this process gives us a clue. Even though, as with any distinction, we may make errors, we can still designate in the main that there are two people and not one. When we are wrong, such as when we punish the wrong twin for the acts of his twin brother, we can realize it and correct ourselves. Of course, we may still be making an error. What if the twin lied? As mentioned, the fact that we can correctly distinguish between twins is important in cases where clear logical reasoning must be performed. A teacher of twins would have to unambiguously separate them when planning a field trip, to know how many pairs of children should be enrolled on the bus and how many must return with it. The math is discrete. No vagueness is permitted. And the last word, permitted, gives us a clue as how to resolve this riddle. The reason our mind distinguish otherwise identical twins always comes back to the fact that not distinguish them creates problems for us. If the difference didn't matter, we would have no reason to make a distinction. Consider, for example, a web browser running on our computer, which on a certain day updates to a completely different version, but which appears and functions largely as before. By default, our mind will continue to respond to similar experiences in similar ways. We would not care that the browser was swapped with its twin, nor identify as it as different, because the change causes us no problems. Any distinction will always be on the basis of which it is necessary, um, and necessary implies that it is relative to an immediate motive. We would only start to conceive of new software version as a different entity when it causes us issues the old entity did not, um, or actually resolves the issue the old entity had. And uh, we want either to revert back to the old version or like appreciate and praise the new one as a better one. There must always be a motive, a reason, um, even if the reason is simple desire to be pedantic. And the same is true of the twins. Treating two separate humans as a single person based on appearances will lead to problems. There are cases, however, in which no distinction between the twins needs to be made. If they share a taste in clothes, their mother may purchase clothing for both while treating them as a single unit. Similarly, a callous bully may call the twins by the same name without any twinge or concerns. Finally, a person unaware that they were twins will only recognize this fact when it causes them confusion or embarrassment. The need to distinguish them by finding some discriminating input only arises if there is a problem context that drives it. Nothing in the stream of input itself can trigger this distinction for us. In some cases, minute differences must be carefully taken into account. In others, enormous differences can be safely ignored. The question only remains, does the person care? And with this said, I'm ending part 1 of this presentation, and next week we will be having a concluding part of this presentation. But I like to come back to the beginning of this presentation and tell you that again that my name is Paul Arsov. I'm the founder of the Decentralized Web project. We did release a marketplace and collection of NFTs, and recently we started working on a project relating to like power management and controlling the controlling and managing the power for electrifying and electric vehicles. But first, I like to tell you about our NFT marketplace, what is interesting, what is unique and special about it is that it is based on three-dimensional objects. With these three-dimensional objects, there has to be special software which loads and displays the 3D object, and we decided from the very beginning to instead of using standard choices like for example game engine code Unity or game engine code Unreal, instead of using them we decided to build our own 3D software engine. What it does is it opens a window on a computer screen. It reads the file of the 3D object, it loads the file, it displays it in this window it opens, and it starts animating the 3D object in a way of moving it in a random fashion around the window it did open. But in addition to reading a 3D file, opening a window, loading and animating the 3D object, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition of the three basic voices, the 3D NFTs can speak in each of these three voices can have three different flavors of voices. A voice can be spoken either in a normal speed, in a fast speed, or in a slow speed manner. If we take a voice in a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. If on the other hand we take a female voice and it's spoken in a fast speed manner, then this voice can come as the voice of a funny person or the voice of a little girl. The next additional and important capability of our 3D NFT is the capability of voice recognition. If, for example, you have a 3D NFT which is loaded and moving in a random fashion around a window, you can issue your very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really, wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with who they are. You can ask the 3D NFT to describe something, for example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to reply in few sentences about Web3 or about decentralization or about the country called Russia. You can the next and actually last but not least important capability of the 3D NFTs is the capability of seeing them in real 3 dimensions. Currently, the 3D NFTs have a version which is projected on flat two-dimensional computer screen, and we are using our imagination to imagine the 3D NFT in 3 dimensions. But we are going to be having a version of the 3D NFTs which is going to be displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT marketplace, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is typed all together 3D NFT. Then there is dot, then there are 2 words, decentralized and web, and they're typed all together, decentralized web. And then there is dot, and it ends with org. Once again, 3dnft dot decentralizedweb.org. On the top of the main page and every other page of our website, you are going to see several links to pages, and one of these links is linked to accessories. You can click on this link and you're going to see that we're offering special glasses. You can click and order 1 pair of these glasses, and when you receive these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can, when you receive these glasses, you can put these glasses on. You can request a displaying of the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFTs and our 3D software engine, but I'd like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance, and our blockchain instance runs Ethereum software, which is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain, it runs on Polygon Matic, it runs on Avalanche Avax, and it runs on many other blockchains currently in existence. By running our own blockchain instance, then we do not require our users to pay gas fees for deployments of the smart contracts for the non-fungible tokens, and they do not pay gas fees for transactions of transfer of ownership from one user to another user. By running our own blockchain instance, then we allow our users to use multiple crypto coins to buy our 3D NFTs and receive proceedings from sale of the 3D NFTs they put for sale, and somebody buys these 3D NFTs. And currently we have 4 different choices of crypto coins for buying and receiving proceedings from sale for our 3D NFTs. The choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and selling with crypto, we have a second parallel and independent way of buying and selling our 3D NFTs, and it is done entirely in fiat currency. I can give an example. For example, let's say you're a user, you come to our 3D NFT marketplace, you click on the composite image of our first collection, then you see all of the 3D NFTs in our first collection listed. You see one 3D NFT that you like, you click on it, and then you're going to be presented with a short video of this 3D NFT as it is moving, and then there's a drop down menu, and when you click on this drop down menu, you're going to see selection of payment between 4 crypto coins, and a 5th selection of paying with fiat currency. Let's say you click on this 5th choice, you click on the button to advance next, and then you're going to be presented in a page where you have to put the number of your debit or credit card, expiration date, and CVC. When you click on the button to make the payment, then what is going to happen is there is going to be a transaction and payment conversion from your national fiat currency to US dollars, and this payment is going to be deposited in our bank account in US dollars. We're going to follow this action with the second action and transfer of the initial ownership from our 3D NFT marketplace to you, and now you become the first user of this 3D NFT. Let's say you play with this 3D NFT for a while, and then at some point you decide to put this 3D NFT for sale. Let's say there's a second user who comes to our 3D NFT marketplace. They browse through the 3D NFTs. They see and like this particular 3D NFT that you did put for sale. They click on this 3D NFT. They select to pay with fiat currency. They put their debit or credit card. They make the payment, and then what is going to happen is there's going to be a conversion from the national fiat currency of the second user, which could be different than your national fiat currency, and it could be different than US dollars. And this payment is going to be converted to US dollars and deposited in our bank account. We are going to follow this action with a transfer of ownership from you, the current user, to the second user, and now the second user becomes current user of this 3D NFT. We're going to follow then this second action with a third action, and transfer and conversion from US dollars to your national fiat currency, and this transaction is going to deposit to make a deposit in your national fiat currency in your bank account, the payment for the sale of the 3D NFT. And with this set, I'm going to end talking about our 3D NFT marketplace and collection of 3D NFTs. And I like to tell you about the second project that we're working on. And this project relates to the increasing number of electric vehicles which are coming to every country of the world, and the drive towards replacing electric vehicles, replacing internal combustion vehicles with electric vehicles. With the exponential growth of electric vehicles, there is going to be become a problem charging of these electric vehicles, and currently charging of the electric vehicles is made in a way of which resembles the gas station model, where internal combustion engines, they're coming to a specific location called a gas station. They come to a specific column, they connect the pump to their car to their car, they load fuel, they make a payment for the fuel they load it, and they leave the gas station. In a similar way, there are special locations where electric vehicles come. There are columns with cables which the user can connect to their electric vehicle. They can start charging. They can stay in their vehicle and wait for a specific amount of time. Then they can make a payment for the electric vehicle. They load it in their vehicle, and they can leave. But we are with the exponential growth of electric vehicles, we are considering that these electric charging stations, made in the face similar to gas stations, are going to become insufficient to charge the exponential growth of electric vehicles. So what we are proposing is the model, the parking lot model, where the electric vehicle owners can charge their vehicles either at the parking lot of the apartment building where they are living, or the parking lot of the building that they work during the day. So they're going to charge either between the work day hours, let's say 9 to 5, or in the evening hours between 6, 7, 8, 9, 10 o'clock, and the morning hours 7, 8, or 9 o'clock time. So with this parking lot model, we're proposing a specific number of products. These products are going to be having near-field communication reader, which is going to read either the debit or credit card of the user, or they're going to be reading the token of the user, which the user did register previously on our website, and they could then identify themselves to the charging station. They can connect a charging cable at the point of the parking lot, and they're going to start charging during the hours their car sits in the parking lot. Like these products that we're building, it is going to like contain also like switch which like after the user identifying themselves, the switch can turn on. They can start charging their cars, and they have a choice of percentage they can select for charging of their cars, either from 10% to 90% doing charge for their car. And then they could select also the period of time for charging of their car, so that, for example, they can select charging with a cheaper timing rate for electric power consumption. For example, if their nighttime rate for electric power. And with this said, I'm ending talking about the second project that we're working on. I can tell you the name and the URL of this second project, so you can check the progress on this project. The name and the URL of the website is power.rstack.com. Power is the ordinary word for power, and then there is dot, then I can spell the letters of this abbreviation. It's Alpha Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether this RStack, and it ends with com. Once again, power.rstack.com. And with this said, I'm ending this educational presentation. Thank you for coming. Thank you for viewing. Stay tuned for part 2 of this presentation. Have a nice day, have a nice evening, and goodbye.